This is Dr. Carroll, and this video is about file input using a scanner object. So there is more than one way to read in data from a file, but because I've already covered scanner objects in another video, let me start with this approach. So one of the best reasons to use a scanner object to read from a file is that the scanner class has several methods to be able to parse the input stream. But before we can do that, we need to know about the file class. So this has been included since version 1.0 of Java. And so the first thing we need to do is let the compiler know about this code that's already been written and around for a long time with an import statement. Import java.io.file. Now there's 4 constructors, and so the one I expect that you're going to be using the most is this one that just takes a single string and it's going to create a new file instance by converting that pathway string into some abstract pathway, and then it'll just have this entity that it keeps track of a file using that. And so let's see that. So we need our file name. I'm just going to use data.txt. It could be something from the user or whatnot. And so then we want to declare an object reference, so we do that by specifying the type, which is of type file. Our variable name we can choose. I've chosen data file object. And then we want to assign it a new instance of a file object. So we use new, and then we call the constructor. We specify this constructor here, file, and then we want to pass it file name. That's it. We're good. That's what we need to know about file. That it takes a string and it associates with that, and it stores it and understands all the nuances about a file. So now let's move on to the scanner class. If you haven't already, checked out my video on the scanner objects. And now there's several constructors for the scanner class, as we can see here. And what you've probably used before is this one, the system.in, which would be input stream. And so that's what you probably used before, but we're going to be using this one where it's taking a file, and we'll come back to this one in just a minute. And so that's what it's doing, and so it's producing files from a values scanned from a specified file. Okay, so let's see how we can do that. So let's copy in the code that we've already done for the file class, just to be explicit here. And then we need to declare a scanner object. And here, and when we do that, we need to let the compiler know, hey, here's all the code that is associated with it, its definition, all of that. Now, as you'll see in a minute, let's break out the traditional declaration and instantiation all in one line into 2 lines. And also, let's specify this as equal to null, which is what it does by default, but let's be explicit here. And so since it's an object reference, it stores on the stack the location in memory where the object goes to. And so we don't have anything that it goes to yet, so we need to specify that with a special value, which is null. And you can see it's colored here, suggesting its relevance, and it's not just a variable, but it has special meaning in Java. So now that we've done that, then we can specify file scanner to a new scanner object. Now here, I've left the constructor empty for now to show that we're going to pass it this file object. Now, if you want to just put the new file name right in the constructor here, that's fine, because what is new file going to do? It's going to return a file reference, and that's what it needs here. And so you'll see that commonly, that you've just developers have put the 2 in 1 to get the job done. Now, remember over here it says throws file not found exception. Because now we're opening files, it might say, hey, that file doesn't exist. What are you trying to pull here? And so it's going to throw an exception. Now we'll cover, I'll do another video on exceptions later. But so what we need to know now is we need to handle that exception. And there's 2 general ways to do it. Let me show you one. And for now, until my other video comes out, just copy and paste this code, please. So what we need to do is this line of code, this last one that we have here, could throw an exception, and so we need to handle it differently. So what we do is we put it in a try catch block. You can see the try statement here. Try is a keyword, and then we open it up with the brace, and then we have a catch, just like an if-else kind of an approach. And so what the try does, it says, hey, I'm gonna try this code and see if it works, and if it catches an IO exception while trying to execute this code, then it's going to come down and execute the catch block. If it doesn't catch any IO exceptions, then we never execute the catch. And we'll stop executing in the try block as soon as we get an IO exception. For example, here, if the input file object doesn't reference a file that exists, it will never assign to file scanner, and it'll still be null because it'll stop before it does the assignment, jump down, do the catch. Now, notice the coloring on IO exception here. Well, that's a object type, and so we need to let the compiler know about that object type by including java.io.io exception. Now, you'll see some people on the web do import java.io.star. I think that's a bad habit. So just specify what you need, at least initially, so you know what packages are what. So now that we have this catch block and we've let the compiler know about it, we can print out a trace for that exception. So the IO exception has a method called print stack trace, which will let us know what called what, so that we could figure out where this bug is. Now, this is a simple example, but as you can imagine, it could get a lot more complex. Now, if we can't open the file, we're kind of at a loss here. We either need to rewrite the code so it could loop back and ask the user to try another file name, or we could just simply say, I'm out of here. We're exiting, and we're exiting now, and with the return value of 1, so I'm done. So for now, it's if you can't handle the exception, there's nothing you're going to do, then exit so the program doesn't continue to execute. Okay, so now with this try block in place and hopefully a file scanner that works, at least we won't continue in the code if it wasn't able to open up a scanner and associate it with that. Create a scanner and open up a file and associate it with that file. Now we have all of the methods that we want to use with scanner objects. So we can use a next line, a next int, next double. We can use all of these methods to get out the data exactly how we want it. And there's more not shown here. But now, if we use these, they'll just read one word, or one line, one integer, or one real number, respectively. But usually, when reading a file, we want to read everything, or said differently, until there's no more to read. And so to accomplish that, we often put it in a while loop. And so what we put in there is we keep looping until it doesn't have a next token. And so hasNext doesn't advance the read position marker. It just says, hey, I'm going to peek in here and see, is there something else, or are we done? So at the end of the file, it says false, returns false, and so we exit that loop. We could have had an implicit equals true here, but so this loop will continue until it doesn't have any more. Now, as written, it'll be an infinite loop because it'll go into the loop, won't do anything, so it won't change the read position, and then it will just come back and test it again and test it again. So let's put something in the loop. So in the loop is where we're going to read from the file and then process each read we do. And for simplicity, as an introduction, we're just going to read an entire line, store it in a string, and then just display it. You probably want to do something more interesting than that, but that gets the ball rolling. Okay, so let's see a demo here. Let's see scanner. All right, here we have some code that's very similar, okay, except we're opening a different file. Let me show you the contents of that file. So pretty straightforward file, right? Just 10 single digits. It was small enough we can wrap our head around it. And we say, hey, I want to associate an object with this file. I'm going to try to open this scanner class, and if I can, then I'll skip over the catch, and then I'll keep reading in until hasNextInt fails. And so we know it has an int, so let's read it. We're going to store it in just this temporary variable num that only has a scope inside the loop, and then we're just going to display it for simplicity here. And so let's execute it. Let's compile it and execute it. Okay, Java C, it's called scanner file example.java. Woohoo! No errors. Okay, and let's run it. Sure enough, it reads in each one of those lines and displays it. And how does it know? Well, it reads in the first line. It's right at the beginning, and we peek ahead and we say hasNextInt, and it's true. It returns true because it sees the 0. We read the 0, display it, come back. The read position marker is in between the 0 and the new line, and it says, hey, if I try and do a nextInt, will it be successful? And this returns yes, you'll be able to get 1. So we say, okay, great. We read 1, 2, 3, 4, 5, 6, 7, 8. It reads 9. Now the read position marker's in between 9 and the new line. It comes up here and it says, hey, if I try and read an int, will I be successful? And it says, no, the only thing left is a new line, and then it's the end of the file. So it returns false and then comes down past the loop, and then we're done and we exit. Now, just to show this, let's rename this file to does not exist.txt, which doesn't exist. Let's recompile it, and it compiles right because this is a runtime error. We run it, and now it hit the catch statement. It says, hey, java.io file not found exception, does not exist.txt, no file or directory, which sounds kind of redundant, right? But it tells you where it was. We were in file stream open, and then it came from scanner. We didn't write that code. Aha, we wrote this code. Well, me. Scanner file example.java line 12, and that tells us where it was when it was executing, when we had the problem, so we can go track it down. All right, go write some interesting code.